Hey everyone, welcome to Technologic. For all the new viewers out there, this video series will help you to unravel the complex technologies in the easiest possible way. So if you are new, subscribe to my channel so you can't miss them. And today we are starting a new topic: why AI is so expensive to run. So you might have already heard this popular line saying every time you ask ChatGPT something, you are basically melting the GPUs. So these words are said by none other than Sam Altman himself, the founder of OpenAI. But are those words actually true, or it's just a myth? Yeah, well, silicon doesn't melt that easily. So basically, it's just a metaphor. But what about the power connectors? That's the real story here. The power draw for modern AI is so intense that they can literally melt those wires. It is true, and there are a lot of real world cases observed where plastic power connectors literally melted as well. So it's all due to the power draw and heat produced. So the question here is, why does thinking cost so much power compared to a normal Google search? So in order to understand this, we need to know the difference between retrieval and inference. So when you Google something, it is called retrieval. So it is simply like the computer just runs to the library, grabs a book, and show it to you. It is fast, lazy, and uses a very little energy. But when you ask something to ChatGPT, it is called inference. The computer isn't finding an answer. It is manufacturing one from scratch. And in order to do that, it has to perform billions of mathematical operations for every single word it generates. So on an average, a single Google search uses only about zero point 0.3 watt hour of energy. But a single ChatGPT conversation can use around 5 watt hours. So see the difference? That means one AI query can use over 10 to 15 times more electricity than a standard search. So literally speaking, the chips don't melt. But figuratively, we are stressing the power grid far harder than ever before. But here's the scary part. All that electricity creates heat. And to cool that heat down, we aren't just using fans anymore like in olden days. We are using, any guesses here? Yeah, water. So how much water does your chart actually consume and why it is consumed? We will see all about that in day 2. And I'm sure you'll get amazed by that. So stay tuned and subscribe to my channel so you don't miss it. Hey everyone, welcome back to Technology. So today, we're at the day 2 of our new series, Why AI is so expensive to run. So if you haven't watched the previous video, I highly recommend you to check it out for better understanding of this video. So in our last video, we learned that AI uses 15 times more energy than Google search. But why? What is computer actually doing here that is so hard? So in order to understand the pain of a GPU, let's do a tiny experiment. Yeah, no math skills required, just think and stay with me here. So if I gave you a simple sentence like this, the sky is followed by a blank, you'll probably say blue. That felt instant, right? You don't even need to try, because to you, that was one simple connection. You just know it based on your life experiences, right? But an AI cannot just know things like we do. It does not have intuition like us. It only knows math. And to generate that same word blue, the AI has to mathematically compare the sentence against an enormous number of possibilities here. So in simple words, it means the AI need to compare every token in its vocabulary. So let's say ChatGPT has 300,000 tokens or words in its vocabulary. Then it needs to think like, is it green? Or is it red? Or is it a car? And then it calculates the probability for everything. So while you just did one easy thought here, the GPU has to perform roughly billions of mathematical operations just to pick that one word. And it does this for every single word. Now this is where physics kicks in. Every time the chips does one of those 350 billion calculations here, it pushes electricity through a tiny wire. Because zeros and ones are actually pulses of electricity flowing and stopping, right? So this push creates friction, and friction creates heat. Now imagine doing that same process billions of times per second on a repeated loop. The heat will be instant and extreme, right? So how do we keep these super brains from burning up? So any guesses here? Yeah, we just simply drown them. We use the ultimate coolant known to our existence, water. So data centers actually use massive cooling towers that literally evaporate water. So it does that to keep the air cool around the GPU. And the cost? Yeah, it is estimated for every 20 to 50 questions you ask, the data center consumes around 500 ml, which is like a bottle of water. So next time you chat with an AI, remember this. You are not only using power, you're also using a large amount of water as well. Also, we haven't talked about the most expensive part yet, the chip itself. So in day 3, we will look at the most expensive object in the history of tech. Subscribe to my channel so you don't miss it. Hey everyone, welcome back to Technologic. So today we're at the day 3 of our new series, Why AI is so expensive to run. So if you haven't watched the previous video, I highly recommend you to check it out for better understanding of this video. So in our previous video, we learn about the massive energy AI uses and the enormous amount of water it drinks just to cool down. But today, we are looking at the most expensive part of the entire puzzle, the brain of AI, aka the GPU. So this is called the NVIDIA H100. It is currently the most wanted object on the entire planet because one single chip can cost you anywhere between $25,000 to $40,000. To put that into perspective, that is the price of a brand new Tesla. And that amount is all for just a piece of silicon chip. And the funny part is that it is just the size of a postage card. Listening to this, you might ask why it is so expensive. Because it is not just about the materials, it's the complexity it holds. This small chipset has over 80 billion transistors packed into it. Let me give you a simple example in order to understand how complex it is. So, if you tried to count them one by one, it would take you over 2500 years to fully count them. But here's the secret, it's the most powerful thing on this planet right now, as it can handle over trillions of operations per second. Remember the calculations we saw in day 2? Yeah, this chip can do that in less than a second. But there's a hidden cost here. Any guesses? Yeah, it's the lifespan. Because these chips run at 100% capacity 24 by 7 in extreme heat conditions, they don't last forever. In high pressure oriented data centers, these $40,000 chipsets are often replaced for every 3 to 5 years. Because heat, voltage stress, and constant operations degrades the silicon over time. And with that, let's put an end to this series. And before signing off, let's summarize the entire series in just a minute. So every time you ask AI a question, you are triggering a chain reaction. From pulling 15 times more power than a regular search to evaporating a bottle of water and then slowly wearing out a $40,000 super chips. So the free AI we use every day is actually the most expensive resources humans have ever built. So use it cautiously. And thanks for watching our series. So if you want to see more unraveling of complex tech stories like these, check out my previous series on Transformers versus Diffusion and subscribe to my channel for more amazing videos like these.